Welcome back, folks, to the Get a Grip on Lighting podcast. On today's show, back again is Greg Galluccio, Senior Vice President of Product Management and Engineering with Energy Focus. Greg joined Energy Focus in 2021 and serves as Senior Vice President of Product Management and Engineering, responsible for developing, directing, and implementing Energy Focus's product strategy, engineering development, and portfolio offering. Greg brings 35 years of diverse experience in the electrical and lighting industries. He began his career at UL, Underwriters Laboratory, that's right, where he led engineering teams in various product categories before becoming the director of UL Canada's operations. In 2004, Greg joined the product management team for Leviton Manufacturing, never heard of them, and later became director of LED business development, helping Leviton navigate the transition from legacy lighting technology to LED. In 2015, he joined Maxlight Inc., where he was Vice President of Product Development and Engineering, overseeing Maxlight's extensive product portfolio, R&D, product management, and sustaining engineering departments. Greg has a Bachelor of Science in Electrical Engineering and a Master's in International Business from Northeastern University. But before we talk to him, we're going to talk to the other Greg, Greg Eric. We're going to talk about Energy Focus. Greg, you got to go to energyfocus.com. And we got to check out their red cap, their N-Focus, Powerline systems. What do you got, Greg Eric?
Yeah, so let's just talk. We talk about sustainability a lot on the show, and keeping your fixtures. You don't have to replace them. A lot of times you hear somebody say, "Well, we want to dim it, or we want to color tune it, or we have emergency lighting. We got to replace the whole thing and start over." You don't with their products. The N-Focus allows you to bypass the ballast, remove it, wire it direct to the line, so you don't have to do any additional wiring. Right? It's all ready to go. It dims it in the tube, and it changes color in the tube as well. So both options there. And then the red cap is bypassing the ballast again, and the emergency capability is built right into the tube. So easy to replace down the road. You don't have to buy brand new fixtures, go all expensive. You can get it all done with Energy Focus.
And I have N-Focus right here in the studio, Greg, dimming the lights right here above me.
Yeah.
And so, you got to go to ENERGYFOCUS.com. And you know what? There's a lot of talk about sustainability in lighting. And I think the cornerstone of sustainability always is less waste. And Energy Focus has been committed to reusing existing sockets since I spoke to them many years ago. And so, they're a leader in this area. Before it was cool, Energy Focus was doing it. Go to ENERGYFOCUS.com. So original. What's happening, Greg Galluccio? Welcome to the Get a Grip on Lighting podcast.
Thanks. Good to see you guys again. What was it, about 2 years ago? Give or take.
Yeah. That's what that's what I was wondering is when it was. And 2 years ago, you were doing a lot of different unique videos and kind of highlighting a lot of the things there. And now you're with Energy Focus. Tell about the transition or what's going on there.
Actually, it made perfect sense because if you recall, when we were speaking about my videos, I was talking about how difficult it is to sell lighting control systems into the commercial space. And I had, laid out what I thought were the top 4 or 5 reasons that it's been very difficult. And by the way, guys, it's still on the commercial side between 1% and 2% penetration of sophisticated control systems going into the commercial space. And we thought it would be much higher. So there's definitely some impediments there. And when I was making those videos, I was also consulting with a few companies, including Energy Focus. And Energy Focus, lo and behold, had a system that solved a lot of the problems that I was talking about in those videos. So ultimately, they convinced me to come aboard and help them bring the system to life.
The impediments being that the customer has no idea what they're buying or what they're buying it for. That's probably the impediment. And I think, not to make this into an advertorial or anything like that, but I always found the N-Focus system a way to give people tuning and controllability without a huge increase in cost, inconvenience, commissioning, apps on phones, stuff like that's kind of fussy. I found a lot of control systems very fussy. I've broken one here in my office by turning it off and on 50 times until it reset all its settings in mid-tier, just played with it like while it was commissioning and turned it off, eventually broke. I think the reason why the uptake is low is, in my opinion, is simply because there is a balkanization in marketplace. Everybody's doing their own thing. And there's not a focus on customer need. There's a focus on seeing who can make the coolest, craziest thing. And what are your thoughts on that, Greg?
So a few things, like you really hit on a lot of the stuff. Um, it's definitely that the customer is not aware, and it's not the customer necessarily end use customer that specs out the system, right? So
Mm-hmm.
if you have like a commercial building, there's a building manager who's being incentivized by utilities and possibly codes to put in some kind of a sophisticated lighting control system. But the people who live, work, and play in that space, they're not comfortable with a sophisticated control system that they have to learn to use, right? So it needs to be, first of all, your control system in that situation needs to be invisible. It needs to be on, off, dim. How do I do that? Oh, it's obvious. I'm not going to read an instruction sheet every time I walk into a conference room. So that's one. The other is that there are some spaces out there that will never really be able to use wireless technology as it currently is. So most of the sophisticated control systems that are on the market are wireless, and that works really well in residential. If you look at the actual penetration of residential control systems, it's pretty high. People are using Alexa to control their lights, and everything is just really cool. Except that, if you're one of those people who do that, you know that there could be any given morning that you might wake up where suddenly your hub is down, or the internet is down, or for some reason two devices are not talking to each other because they forgot they're supposed to be paired. And then you've got to spend a half hour, an hour, or something like that getting them back online, calling customer service. But as a residential owner, you do that. It's annoying, but you do it. Okay. But how about a prison or a hospital
Sure, critical
or a school,
infrastructure. Critical
a
infrastructure.
critical any that's a disaster. You don't have an hour to get your system back online. Those lights need to be working, right? And the third is security. So systems that are wireless are inherently hackable, and so government installations will not use them. Military installations won't use them. Now, there's so the Enfocus system, not to be an infomercial or anything, but let's talk about just power line control. So,
Sure. Let's call it
whoever
power line
might be
controls.
doing, let's call it that. Um, it's a way of sending signals over the supply lines that are already there. So again, you don't have to bring in control wires. There's no 0 to 10. There's not any of that. If there's a black and white in the wall, you put a controller in, and you send signals over the power supply line to a fixture that has a receiver fitted to it to understand those signals and then be controlled, right? Now, why isn't everybody doing this? Well, a couple of reasons. Number one, there's some technological hurdles to this, which some companies have overcome now. And number two, there are limitations to the system. You can't jump transformers. You can't go past a circuit breaker panel, that kind of thing with a power line control. So it's a solution for small rooms, classrooms, assisted living facilities, hospitals, clinics, where if you want to do something that's secure, plug and play, really simple, plug it in, and no additional wiring required. There it is, and it's stable and it's reliable.
What are the technological hurdles? I mean, I know they might get pretty advanced, but can you sum it up for us?
Yeah,
Like what
I'll
specifically?
try to explain them without getting too technical. But what a lot of people did in the beginning, when it's like, okay, let's send some digital signals over the power supply wires, it's AC power going through that wire, right? And
Mhm.
everyone's first thought in how to do this is, well, let's superimpose a little 5-volt signal on top of the AC power line. And the problem with that is that on the receiving side, the power line is dirty. If there's generators turning on and off in the building, if there's some grunge on on the power supply line, which there almost always is, how does the receiver know that this is a signal and this is a glitch? And so you have to put then very expensive equipment in on both sides, modulator, demodulators, to then decide and clean up the line and figure out what's a glitch and what's a real signal. That's not the way it's being done now. So anyone who's listening to on today's show who has recall of some of the older systems that came out, there were problems with those systems. They didn't always recognize the signal that was coming, or sometimes the signal would be recognized that wasn't a signal. It's being done now in a different way. Instead of trying to superimpose the 5-volt signals on top of that power supply line, um, you can chop up the power supply line and in very small slices, and every one of those slices is unmistakable as an intended signal. And then you can even say, well, let's just send 4 of those. And when the receiver sees 4, it knows it's got a signal and not a glitch, and it waits for the next 16 bits. So you're sending 16 bits across the power supply line in a very reliable way. The system always recognizes a signal and rejects garbage. Does that explain
So
it okay?
the people, yeah, no, for sure. So so everybody's doing wireless because it's a little easier to wrap their head around, or a little maybe cheaper to do. Is that kind of the deal?
No, it's not cheaper. Our system is actually very cost effective. I mean, you got to put radios in both sides of everything if you're going to do wireless, right? Um, another limitation is that you can't send a lot of data, and you can't. We won't be streaming Netflix over the power supply lines anytime soon, right? So if you're going to be doing really sophisticated control systems that are sending all kinds of data back and forth, maybe pulling in camera signals and stuff like that, as well as doing lighting control, you can't do that with power line control. Um, it's a little bit slow, although the technology now we've managed to get to the point where it's imperceptibly slow. So in the past, some of the systems you would press the button for the lights to turn on, and they would not instantaneously turn on in terms of your own perception, right? And that can be really unnerving for people who are used to instant on and instant off on light switches, which is all of us, right? That's been also improved to the point now where it's imperceptible.
So do you think to ever get to the point of making sense of controls, we just need to rewire everything? Is that where it needs to get to? Every building
No,
rewired.
I think the great thing is this: in cases where you can tolerate the shortcomings of Bluetooth and Wi-Fi, um, you can do really sophisticated stuff. You can control entire campuses from a single control system point. You can do all that kind of stuff. And that's where those systems are going to go. It's going to take a while, but there's a few companies out there doing Bluetooth and Wi-Fi that have upped their reliability quite a bit. So it's going to become more and more accepted as we go along. And in some cases where that is just simply not going to work, and those cases I pointed out earlier, where the government buildings, mission critical sites like prisons and hospitals and schools, um, we may move to a power line control situation. Another area where power line control, this is what surprised me because I hadn't thought of it, is quite popular now, is that in places where they're retrofitting schools and classrooms and things like that, a lot of these schools do not have 0 to 10 wire um, in the classroom. And to pull 0 to 10 wire throughout an entire school, 20, 30, 40 classrooms, is rather expensive. It's in the tens of thousands of dollars to do that. Well, power line control, even if you just want to do dimming with it, um, put it into the wall. The wiring's already there for you. Put the correct tube or fixture into the wall, into the ceiling, and now you're able to dim anything that you want to dim. Color change if you want to do that too.
Are there power line fixtures? There are power line controlled color tuning and dimming fixtures that you know of?
Yes, so we have done. we've expanded outside of tubes, so you can do it in a
Okay.
tube. You can put really all you need is a pretty small chip to figure out what the signal is that's coming in. And so if you install that into a fixture, so now that brings me to the fourth inherent problem with power with all control systems right now in lighting, and that's interoperability. One of the big things that has been biting people who are early adopters of commercial controls is, well, I just did half of my building with the blah 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 control system, and now I want to do the other half of the building, but all my fixtures are not compatible. They won't talk to my controls. Now what do? I have to go and replace all of my fixtures. I can't just put a new control in. So one of the things that's possible to do with Powerline control is create a little module that translates the Powerline signal control to 0 to 10. And you just take that little inexpensive module and you drop it into any fixture, right into the driver compartment or something. And now that fixture is able to be dimmed and color tuned from a Powerline control switch.
So from a kind of going back to the wireless side of things, is Bluetooth going to be the choice going forward? Is that going to be I'm trying to think of the term to use, but the generally practiced wireless connection
I think
mode,
so.
whatever?
I think
Okay.
so. Yeah, we're all of the real research and product development and everything on the wireless side appears to be on BLE, right? Um, and it's getting better and better and better. So if you look at the wireless side, you're right. I think it's pretty sure it's going to be Bluetooth. You look at systems like
So
Avion and a few others. I mean, those guys are doing some really cool stuff.
so if you're a manufacturer of lighting, which you work for one, should you be doing both? Should you be having a wireless option and a power line option for this, or what's the move?
Here's why. Here's why I would not recommend for my company to be doing both.
Okay.
The development cost of a wireless control system is rather high. And to be perfectly honest, the development cost of any sophisticated control, and when I say sophisticated control system, meaning a system that can do more than just on off dim, a system that can gather data from the lights that are in the ceiling as to their state or whether there's a problem with the driver, systems that can transmit, help do access control, um, transmit messages in two directions, all that kind of stuff. That the development costs are rather expensive. So, and then the time and the difficulty in getting to payback. I always show people a picture of a lighting installation in like an ice cream shop that I found. And there's like 800 globe lights being suspended from the ceiling in this ice cream shop. It's really cool. And there's a switch controller in the wall that does all the dimming and everything else, right? So, who made the money on that job? The guy who put in the lights or the guy who put in the wall switch? Right. So it's the guy who made the lights, right?
Hmm.
So the payback on a $10 million development of a wireless control system is difficult because the real money is being spent on the light fixtures themselves. A lot of guys didn't understand that when they started pouring money into this. Go ahead.
Well, I know you don't worry about when Greg and I are pointing at each other. That means that who's going to ask the question next. I got like a
Yeah.
sheet full. I don't know if the listeners, watchers, any. I got like so many questions. I don't even know where to start. Um, to be honest with you, let's start with payback, like value proposition. You know, I don't know if you ever heard of a guy named Nicholas Nassim Taleb. I think maybe he was super popular. He wrote The Black Swan, Fooled
Oh
by
yeah, yeah, yeah.
Randomness. He has like he calls it the inserto, all his books, anti-fragile, all these things. One of his hypotheses is that the older some technology is, the longer it is to outlive its upgrade. So, for example, checks will outlast e-transfers, or the light switch will outlast any Bluetooth control system anyone cooks up. In 100 years, you'll still have a light switch, but Bluetooth will be for long forgotten about. And he has like letters will outlast emails and books will outlast ebooks and so on and so forth. And so the older and more, a longer a technology has had its life, the more likely it is to persist into the future. And so what's interesting about that particular idea is that everyone all there's an entropy to existing technologies, which is very difficult to overcome. When people walk into a room, if you live in a Western country or you grew up in a Western country, you walk into a room, you look for a light switch if the lights are off. Okay? Even if you're a Gen Z or a millennial or whatever, you don't pull out your phone and try to turn the lights on in that room. Okay? And so that is a persistent entropy.
Mhm.
So then now you get into how can we convince people to take on this without giving them a light switch, without giving them a dimmer on the wall, and all of the fussiness and problems that come with it. It's almost as if the lighting control people have not, in the interior environment that is, and I want to talk to you about outdoors at some point in this recording. It's
Mhm.
almost as if people have not acknowledged the scale of the mountain in front of them. It's like, and whether or not the people that they are planning these products for even want them. And I'm not talking about new buildings or new construction, which may adopt these things or not. I'm talking about most buildings are already built, Greg Galluccio.
Mhm.
They're already there. And most homes are
Yeah.
already there. And
Yeah.
the average person that I know that has some lighting control system in their home hates it. Okay, they can't stand it. They forgot how to commission it, or they no longer have parts available for it, or what have you. I think the lighting control people need to look at the mountain and acknowledge the scale of it and go back from there to what people are accustomed to using and start with giving them a better light switch. Lutron did it in the 60s by adding a little slide bar to it, which lowered the light level. Energy Focus did it 3 or 4 years ago with their end focus system. And again, this is not an advertorial, folks. I don't give a rat's ass about which way is up or down here. What I'm saying is that on my wall right there, there's a dimmer and a tuner. And it looks a lot like a light switch. And it's
Yep.
intuitive like a light switch. And so everybody that walks in this room looks at that for a second and goes, oh, press that to turn on and this to dim and that to tune. Okay, somebody thought about this from the perspective of someone who might actually use it that's never heard of Enfocus and doesn't want to know about Enfocus and doesn't want their app on their phone. You know what I'm saying?
Absolutely. Yep.
Am I wrong in saying that I don't think the controls people have ever examined the actual Mount Everest in front of them? That
Well, I
they
think they are now. I think they are now because it's bit them. They came
Mhm.
out with these beautiful systems in the beginning. If you let the engineers go, it's all over because those guys are going to put matter transporters into the system that they're designing. While they're at it, why not? And so you get these wildly, and the control panel looks like the inside of a 747. So what end user wants to walk in and see that? Actually, none. So just to your point, you want to see it switch. And I'm going to tell you a fun story. I was at Light Fair International a few years ago, and I got to talk to the head engineer at Samsung, who was developing their lighting control systems in South Korea. And he said to me, "Don't you think at some point we're not going to need the light switch anymore?" And I said, "Well, do you always have your phone in your pocket when you walk into a room? What if you got up to go to the bathroom at night, get out of your bed and walk into the bathroom? How do you turn the lights on?" So he says, "Well, no, it's all voice now. It's all voice. It's Alexa." And I said, "Okay, let me tell you my problem with that. And this is a real life problem. I had a dog that would bark like crazy whenever my wife and I would come home from being out anywhere. We'd go out for 5 minutes, come back in, the dog would be barking like a lunatic, right? Maybe I'm not a good dog trainer, but anyway, if we walked into the house late at night, it was pitch black in the house. The dog is barking at 10,000 decibels, and I'm like, "Alexa, turn the lights on." Alexa, she can't hear me. So we have to stand in the dark until the dog calms down to get the lights on. And the and the Samsung engineer was like, "Oh, wow. How do we get around that one?" And so to your point, there are the simplicity of going to the wall and doing that is something that will never go away.
I'll give you an anecdote.
And
So back to the hypothesis about what is older will last longer. I actually really like to work with basic passive infrared occupancy sensors, switch and ceiling mount, right? And
Yeah,
I just sold my house last week. It just closed on Friday, and
congrats.
thank you. And so I my kids have never turned on off or on a light in their lives. Okay, so my kids have always had a home that had occupancy sensors everywhere in the home, perfectly commissioned, beautiful. You walk in, goes occupancy sensor to dimmer. Just touch the dimmers. Don't touch the aux sensors. Right? That's the message. And
Hmm.
these people could not get over not touching switches. And then as soon as you start touching the switches and turning off all the sensors, the system stops. Like it's like, oh, I can't turn my
Love that
lights on.
door. Exactly.
And this is just basic. This is just a switch. Like, okay, don't you see that thing with the little eye on it, the little sensor on it? Don't touch that.
Yep.
Just touch the light switches. Dim your lights, turn them off if you want them off, or whatever. Just don't touch the sensor. They couldn't do it, and they just I believe they're now ripping out all the sensors because they can't stand it after one day of living there, you know. And so, I mean, that's very very simple. I can't imagine as soon as you go up a level of complexity, it's not one, it's exponential. The
Yes.
maintenance, the hassle, the fussiness, the pain in the butt, and people end up overriding their control systems. I mean, Greg, there was a company in Nailed for a while that all they did was go back and help people understand how old lighting control systems worked
You're
because
right.
people just
Yeah.
overrid them because they couldn't handle the BS. It's like you know what I mean? And so I'm not so confident as you that they've acknowledged the hype. I think they're excited by the hype. That's great. I'm into the hype too. I would love to sell it. But when I take these systems to the streets, when I take them to people that actually buy light bulbs for existing buildings, I always have a very difficult time getting excited in front of a customer. Greg, Eric, can you agree with me on that? When you get into outside of basic occupancy control, the rack aisle lights are on, the rack aisle lights are off when no one's there. After that, do you get excited, Greg, Eric, about all this stuff?
No, I don't. When I do get excited is if they are. And then I say, oh, yeah, yeah, yeah,
Yeah,
here we
yeah,
go. Now we can
sure, of
do that.
course. Yeah, yeah,
Right.
for sure.
That's happened like once in the last 5 years. Not very often.
So two things to that point. That's actually a really good point, Mike. The level of complexity when you go up a baby step in complexity, the complexity of the use of the system goes up three steps. I'll give you an example. You have a system that's programmed to turn the lights to 50% or 30% or something like that after 10 o'clock at night when the building is supposedly empty, right? So now you've forgotten your briefcase and you go back into that building at 10:30 at night where the lights are dimmed down to 50%, and you walk into your office and you click the switch and your lights go to 100%, and you grab your briefcase, and as you're going out you click those light switch again. Does the light go to 50% or off?
This is what I'm talking about. But
Uh,
you know,
the
okay,
answer is the answer is it doesn't matter. It's whatever you want. But if once you do that, you make a decision at commissioning and you say, oh, let's make it go back to 50%. Well, what if you did want it off? Now what do you do? I don't know.
I was
Right?
walking through a hospital last week, okay? And this hospital had retrofitted all their 2x4 T8 system. They had an old lighting control system on it. Now they put in all new LED fixtures. Each one had its own sensor, set to a 30-second time delay. So as you walk through the hospital, and this is not like a broad ranging, extended range sensor that sees 50 feet in either direction. It sees maybe 10 feet in either direction, maybe 8 feet. Okay, it's mounted to the fixture. Okay, it has a 30-second time delay. As you walk through this hospital, the lights are dimming and going higher and dimming and going higher as you walk in front of you. And maybe this feels cool for a while, but as a lighting guy, I look at that and I go, this is so dumb. Like
Yes.
what idiot put these fixtures in here? You're walking through and the lights are going off and then they're dimming and they're going on and dimming and people are walking through and lights are going up and down and up and down and up and down. This is just going to wear out the equipment in that fixture. I don't care what it is that's doing that. That function of going up and down and up and down is a maintenance disaster at some point. How do you fix that if something breaks? How do you fix the light fixture? How? Tell me how.
I, um, I hope whoever installed it is still around. or whoever put that system together is still around, and it's going to cost you.
So, okay, that's the second thing. I want to talk to you about something called electronic smog or signal smog. Have you ever heard this term before?
First I'm hearing it,
So
but
the
I'm trying to envision what it is. But go ahead.
Okay, so what they're saying is, what I've heard now is that there's been beyond an exponential increase, so beyond exponential to whatever is above exponential, sigma or whatever the next step is, in terms of the amount of electronic signals that are around us all the time. So
Yep.
everything's connected, everything has a Bluetooth and a Wi-Fi and all this, and they're all pushing these signals out into the world around us. At what point is somebody able to connect to all those and hack everything? That's the other side of this scenario where, like you said earlier in the show, Powerline is difficult to hack. That's tough, man. You have to get some connector on the power line. You have to someone has to physically be there, old-fashioned 80s thing, and you got to break into the building and connect to Northrop Grumman's, power line lighting control system to get information. And it's only 16 bits anyway, so it doesn't have a camera and a TV thing and everything else. So it's
You're not going
inherently
to get any
secure.
information anyway because it's not connected to their network controller. So
Exactly.
what people are trying to hack is to try to jump it into the bank vault controller, which is in the same building, right? But it's never going to do that.
Exactly. And
So
so you have
yeah,
all these signals that are connected together. All you're doing is you're just punching holes in your security wall everywhere you can. And as soon as one of those devices is connected to some computer that's on some network, you've compromised your security of your building. I don't care what firewall, who you've hired, how many guys you have in India that are managing your network or whatever you got. That is an opening into your system that I don't even know anyone that can explain how that's fragile. But we all know it is. We all know it's fragile. But I don't know anyone that can explain to me why and how it's fragile. You understand what I mean?
well, I do totally understand. Totally understand. And someone will find a way to get through that smog, right? And get into whatever they want to get into. The other thing, it's not just security that the smog creates problems with; it's actual operation. Every year when we go to Light Fair, we set up a booth, and we usually want to get slick and control something in the booth using either Bluetooth or some kind of wireless thing. But by the way, so do the other 500 people with booths, right? So what's happening now is one year we actually brought a little robot that we wanted to just have, driving around in the booth. The thing would not respond or respond to signals at somebody else's booth and actually start leaving the area. It was impossible to make anything work. It's the same deal. The more we introduce that stuff, the harder it's going to be.
Signal smog. I might have made it up. I might have heard it. I don't know where I heard it.
Well,
Signal
you
or
coined the
electronic
phrase.
smog.
I'm going to credit you from now on. If I hear that term, I'm going to be like, I know the guy who coined that term.
But yeah, it's problematic because you look at, even if you open up a phone and you look at the various Wi-Fi signals or the amount of devices that you can connect to in a building, it's endless. It's
Yeah,
endless amounts sometimes, and you
yeah.
you got to think to yourself like, what is this? And then is your lighting system going to? No, we have the 7.215 patch on it. It's unhackable now, and whatever, we patch that and da da da. I mean, this is a game of catch me if you can, in my opinion,
Yeah.
between the hackers and look, computers work both ways, right? So people can,
Yeah.
if the signal's there, it can be hacked. That's the end of the story. Um, okay, let me ask you a little bit about distributed technology versus cloud, like edge technology, as opposed to cloud computing, right? So, what we're talking about when we're doing these Bluetooth systems, we're talking about some sort of hub where there's a controller and somebody that's programming something and they want it to be a certain way versus an edge system where the technology or the smarts is actually at the point of use. So, like a Tesla car's driving system is an edge computing system. It's not taking time to go to the cloud, get the information, and come back down. The computer on the car has the information at the edge where it's needed and makes a decision at that point, right?
Right.
The power line thing seems to me like a bet on edge computing, where it's like, actually, we don't need that much power, we don't need that much information. It's only 16 bits. We're going to put it right at the edge, and then that's where what makes the most sense. Is that, am
That's
I
exactly.
making a right comparison there?
Oh yeah, absolutely, absolutely. And I spoke to some other people who had been trying to develop power line control technology, and they said, "Well, we gave up because you couldn't get it, you couldn't jump a transformer, you couldn't get it past a circuit breaker or a switch or something like that." And I said, "That's true. It's all true, but understand that the market you're after, it doesn't necessarily ever need to do that."
Hmm.
So you work within the limitations and you create a system that works really, really well within that task set, right? And so what we wanted to do was to be able to control, for example, circadian rhythm cycles using color tuning,
Hmm.
and also bright dim, because circadian is not just, we can talk about circadian in a little bit. It's not what most people think it is. It's a little different. And we wanted to create that for the purposes of working with assisted living facilities and all these places where the research is saying this is great stuff for
Hmm.
our patients. I mean, really good. It's not a question anymore. The question is settled. So why aren't these systems being installed? And it's the four reasons we just talked about. So
Oh.
we wanted to work within those confines, and all you need is an edge system for that. That's all you need. So that's what you do. And not to despair the wireless system. We were doing some heavy, slamming of the Bluetooth stuff just now. Those systems are absolutely useful in many, many applications, right?
Oh
And
yes,
you'll
I couldn't
you'll
agree
live
more.
with all those bugaboos. You'll live with them, or you'll improve them, or something like that. But again,
I
the
think
edge system fits
I
in
think
its
they're trying to
slot.
apply I think they're trying to apply the technology in the wrong place. I want to ask you. You worked
Yeah,
at Leviton. You worked at Leviton, right?
yeah.
Do you remember
Mhm.
that little Leviton switch they came out with in 2007 or something? And you crank open the front and you press the buttons, and it has sundown to sunup. And do you
Yeah,
remember that
yeah,
product?
yeah.
Right?
I was not
I
involved in that product, but yes, I do. Yes, I do.
Okay, I sold so many of those, it's ridiculous. And it had a little battery in it. And so if the power went off, it saved its settings. And you could program your latitude and longitude into it, and it would know when there was sundown. You put the date, and then you
Oh
could do
yeah.
all these crazy settings on it. Okay,
Yep.
that product was amazing. Okay, I'm going to tell Leviton, like, that was an amazingly, all the complicated use of that product was at the point of commissioning. Once you commissioned it, it worked great.
Yeah.
I mean,
Did you
it
need
would
a
turn your light.
computer?
No, the
Nope.
sun would go down, your lights would come on, and you could even
Yep.
program, well, turn them on 30 minutes before sundown, and the lights would come on, and it was dusk, and then whatever. That was a fantastic product. What I'm saying is, maybe we're requiring too much computer power to do stuff that only needs 16 bits. Off, on,
Absolutely.
dim is 2, 1 0 and 1 1. Whatever. Like, are we overcomplicating this to the point where you don't need to run, Google's, and what do they call that? Or whatever, Facebook's software, that, this crazy software that uses so much computing power just to run. Do we just need a couple zeros and ones for dim and color and timing? And it doesn't seem to be that
You don't need,
complicated to me.
you know how many different commands you can send with 16 bits? I mean,
Oh, for sure.
16 factorial, right? It's
Yeah,
like a million. So I don't know, somebody's going to correct me on that, but it's more than you'll ever need for
exactly.
lighting. Let's put it that way. And here's an interesting thing, just one example. What's the toughest thing that you have to deal with if you're installing a ceiling fan that has a light built into it?
I think it's making sure this light can be turned off and dimmed separate from the fan at a switch.
Yeah. And what do you usually have to do
You have
to
to
make
pull the
that
fan
happen?
wire. You have to,
Thank
yeah.
you. You got to pull another set of wires down to the
Hmm.
switch, right? Power line control can tell the difference between the fan and the light.
Hmm.
And you can do fan speed control and light control, dimming and everything. All you have to do is connect the power line control to the wall and connect the supply wires to it, and you're done.
Too
So
simple.
if your
Makes too
fan,
much sense. No,
so
I'm
you
serious. Like,
send this set of bits for the fan and this set of bits for the light, and they respond.
Mhm.
yeah, there's this, like, temptation to overcomplicate things. Like, the best you ever, I don't know. Do you like poetry, Greg?
Yes, I like
Okay.
song lyrics. Let's put it that way. Go ahead, same
Okay.
thing. Go ahead.
All right, song lyrics. Yeah, that's good. That's poetry in a sense. The best poetry is written in extremely tight
Yeah.
rules. Iambic pentameter, 12, 14 lines, whatever it is, 10
Well,
syllables per
yeah.
line. But if you read it, you can't tell that it's written in that way with all those rules. It's like the problem with this software issue we have in lighting is that there's no form factors. There's nothing, there's no barriers of innovation. That this is what you have to do with this. You need to turn the light off, you need to turn the light on, you need to dim it, and you need to change its color. And that is it. And you know what? You need a timer which you plug in the latitude and longitude so it knows when sundown and sunup is in that particular geographic location. That's all we need for everything we want to do. But they take it so much further than that, and that's where all the problems come in.
So here's an interesting one also. When I was first explaining our system, our first set of controllers do not have a clock built into them, and yet they do circadian rhythm sequencing. And people were coming up to me and saying, like, well, how does it know what time it is? So the inherent assumption in that question is that it has to know what time it is. It really doesn't. We were constrained, so we had to get creative. And what we did was we set up the switch such that when you first turn it on, you tell it what time of day it is by pressing a certain button a few times. Once it knows what time of day it is, it starts cycling through the day in terms of hours. And now, even when you turn it on and off, that cycle is still going on in the background. So it doesn't need to have a clock. It always knows when it's afternoon. It always knows when it's morning, and it always knows when it's nighttime. Now, there's a little bit of drift in there that's going to happen, and you might have to reset it in a year or two. But we can do circadian rhythm without a clock. So
And I guess that's one of the questions I had is a play on controls. Is it for energy savings or circadian or both, or where do you guys see
Exactly.
it at? Right.
well, it's both. It's
Both.
more than both. It's energy savings, but honestly, energy savings may or may not be the big thing. Right. So we've saved 90% of the energy that we use in lighting just by switching to white light LEDs from legacy lights. Right.
Mhm.
So how much more are we going to save now? Another 4%? The utilities are all over this, but I don't see the equation really myself. I understand that, if you look at the New York City skyline at 11 o'clock at night, it's gorgeous, but what are all those lights doing on? Okay, put occupancy sensors in the building. That takes care of it. The real advantages we have now, many of them are health advantages, and I make fun of the term human-centric lighting. I think it's the silliest marketing term that's ever been invented. It,
Mm-hmm.
it it means it can mean anything. I mean, does it mean full spectrum lighting? Does it mean circadian rhythm lighting? Does it mean flicker free lighting? Does it mean all of those? If it means all of those things, then it means nothing. And by the way, any light that's manufactured is human centric because we're the only beings on Earth that actually make light, other than fireflies. So the thing is, we can we can do health related lighting by mimicking sun patterns and things like that our body's internal sensors need to see in order for us to be at maximum health and have the right amount of sleep. There's studies now showing that infrared levels of non-visible light that we don't bother putting into lights because we don't need it and we don't want to spend the energy. But without it, there's sensors that are looking for that. And by including that, we're helping ADHD patients, Alzheimer's patients, all these people who are suffering because they need to see infrared light. Their sensors need
We
to
need
pick
it.
it
We
up.
need another show to talk about that because
That's right.
there's a reason why every northern culture has a sauna. There's something to that infrared heat. There's a reason why if you go across, you'll see that they all do this with the hot rocks and the steam or a sauna or something. There's something to infrared because heat and light are really the same thing as far as I understand. It's just a wave. And
Yeah, it's a different frequency of, yeah. Mhm.
so when you're talking about infrared light, you're talking about light in the form of heat or some sort of energy like that strikes you, that causes the human body to react. And it's not by accident that every northern culture has a sauna activity going on within their people. That's not an accident. It's not an accident that all humans sit by fires at night when they live in indigenous communities, or they, and these types of things. I wanted to talk about one more thing, but is there, before we get into that, I know this one's going a bit long, and Greg always tries to keep it 45 minutes, but I just want to, because I don't want to open the circadian box, because that could be a whole other podcast.
Do that
but I just say that I don't fully agree with everything you said, just so the listeners don't come back and say, call again, right? But there's an upgrade fatigue that's going on within the lighting industry. And so what's happened is, everybody's used to these revenue numbers. Everybody's used to this easy sale, take out a halide, put in a high bay, whatever. And now we're kind of trying to take this square and push it through a circle hole, and that's lighting controls. It's not a bonanza in the interior environment right now. There's no bonanza available. There's not huge energy savings to be had. All of that's been captured already. We've done it once with the T5s and the T8s, and now we took the T5s and T8s out. We put in LEDs. There's not much further we can go with the existing technology. Even with controls, you're talking about like really picking up the crumbs. So the party's over in that sense, and but there's an upgrade fatigue into controls and with the industry. What I wanted to ask you is, why is nobody focused on exterior lighting with controls? Like, to me, the most obvious, massive business case is to embrace the darkness restoration movement, embrace the restoration of the night sky, and of we get circadian rhythm. Network lighting controls make so much sense in municipalities and along highways for environmental reasons, for crime reasons, to run all manner of experiments. What kind of light helps? What kind of light doesn't help? Can we lower it? Can we shield it? All these different things. But nobody ever talks about it. Somebody wrote me an email saying that I sound like Donald Trump when I say this, but nobody talks about it. Nobody talks about it, right? But I'm serious, Greg. Nobody ever talks about the exterior, which is a massive bonanza for this industry if we embrace darkness restoration, where lighting controls would be an intrinsic part of it. How come nobody ever talks about it? And circadian's there, and everything's there for us. Why are we not talking about this?
Well, first, I'm going to pick that apart a little bit. I think on the street light side and the municipality side, they are talking about it. They're calling them smart cities. And there's a few cities, Memphis is one of them, and several others. And I thought it would really explode. I don't know if it has or hasn't, because I'm not really in that side of the business, where, the functionality of networked outdoor lighting. I mean, think about it. If there's an emergency in the city of Memphis, the police can strobe the street lights in the direction that they want traffic to go to leave the city. Right. Mm-hmm. And if it gets plugged up, they can actually make people turn a different way. If there's someone having a heart attack in an apartment complex, they can strobe the street light in front of the door that the EMS team needs to go, without them having to look for the address. They just go right to that blinking light. Those are amazing advantages for outdoor municipality type lights. And I think a lot of cities are starting to take advantage of that. Nick, but you brought up an interesting point. What about non-municipalities? What about all these buildings with outdoor lighting? What about all these parking lots all over the place? I don't know why that's not being embraced. I don't know why people are not, picking up on that and going and doing some interesting things there. I haven't seen it.
There's so many business cases. You just threw two more on the pile, which I never thought of, which is the use of these lightings to help for guidance in emergencies. Never even thought of that. But I mean, you're talking about, France is going to accomplish dark skies because they don't have enough electricity. Okay, that's not the way we want to do this. Okay, because they're going to run out of electricity, so they're going to turn off their street lights. Like, okay, what I'm talking about is, you have the circadian issue, you have light trespass, you have wildlife, you have flora and fauna, you have all these different areas, right, where we can address this using network lighting controls, color temperature, color tuning, warming everything down to a better level, shielding it, mechanical shields on light fixtures. Where is the experiment? Like, come on, what do you need, $1 million to run an experiment in Chicago, South Side Chicago, to see if lights can decrease or increase crime? Like, come on. Like,
Yeah.
come on.
Yeah.
You don't even have to be in Chicago to control it and observe it.
Right.
I mean, like, come on, folks. Like, this is such an obvious thing. The idea that more light equals more safety is a flawed hypothesis. What we need is to see what can we do with lighting to increase or decrease crime, vagrancy, robberies. Like, let's try it out. And to me,
Yeah.
all of the companies in this industry and all of the institutions that study this, nobody talks about it. Nobody talks about it. And it's the most obvious business case for these Bluetooth network lighting controls to me. And I'm praying I don't have any stake in this. My company would never win that contract, Greg, to do that. So I'm not saying this for any reason that I would personally benefit. I do not own a company that makes light. All I do is sell light bulbs to people. But to me, on the front lines here, it's like, why are we trying to force malls to adopt these crazy systems that we don't know what the outcome is going to be, and it's going to be fussy, and we're not sure it's going to work, and all this sort of stuff, and what's the benefit, and do people really need circadian in a mall, and all this other stuff, when you could take a tenth of that money and go experiment with it in some street lighting somewhere in a high crime area and see if you can make some impacts. To me, it's just such a wonderful idea, and nobody talks about it, Greg.
Well, I think there's probably an entrepreneur listening to this podcast right now who just went, okay, that's a good idea, and hopefully they'll go and work on it because I haven't seen it.
Forget about the entrepreneur.
We could be in a bubble or something. I don't know, but
I'm talking to Pacific Northwest National Laboratory. Like, come on, do a competition for this. Like, kick it up. I'm serious. I love those guys.
There's something about outdoor control that we haven't thought of. That's a inherently difficult, but I don't know what it would be. I really don't.
Well, folks, we made it to the end here. Greg, I know we came in at 6 minutes late for you. I know that's Greg Garrick, by the way, not Greg Galluccio. Too many Gregs around. Too many Scotts and Gregs around. Greg, we got to go to energyfocus.com, and I know that Greg Galluccio works for Energy Focus, but, I really like some of the so originals, ENERGYFOCUS.com.
Yeah, and just to recap, too, he's going to actually be at our NAILED convention diving more into this topic. So make sure you check that out because you can hear more live in person, ask questions, get into it, and you'll talk about it. But back to N-Focus and RedCap, we talked about at the beginning, we talked about in the show how easy it is. And that's what people want when it comes to controls. They want something that makes sense, that's easy, that doesn't cost a whole lot of money compared to a lot of other systems. It's very cost effective and it gives you the ability to control it with dimming and color tuning. And then you have the RedCap too. You don't need a brand new fixture. You don't need a new ballast. You don't need all that stuff. You just bypass it, put a tube in, it's all built right into it. Nice and easy.
Go to ENERGYFOCUS.com. That's right. And Greg mentioned the convention. It's coming up. It'll be about 2 weeks from when this one goes out. November 13th through 16th, Dallas, Texas. Check it out. Go to nailed.org/ I just click on the convention link. It's there somewhere. I don't know what the actual URL is.
September, not November. We're ready.
Did I say November? September 13th through 16th. I'm going bonkers here. I'm just pissed off about this. No, nobody talks about the outdoor. Talk about the outdoor. Talk about the outdoor. And, of course, tied up with Arclight and you, the listeners, if you made it all the way to the end, we love you guys. We love you guys. Thanks for listening. Bye for now.